Okay, so year 10, final question of this paper. I know it's a little bit blurry, there's quite a lot going on here, sorry. So we've got the diagram shows a sector OACB of a circle with centre O, fine. Then we are told C is the midpoint of the arc AB, fine. We're also given a cone here, and the cone is formed by joining OA and OB. So basically, if you joined these 2 points together, you would get this cone shape. Okay, and trying to visualise that in your head, and I know some of you will find that easy, some of you will find that quite tricky, but if you try and visualise how that cone is made out of that being folded together, that'll make it a lot easier. Then we are told the cone has got a volume of 56.8 and a height of 3.6, and we're also told up here this is the volume of the cone. So if we know the volume, we can work backwards and figure out some other stuff. So the volume of the cone is 56.8. I'm going to switch pens. So the volume of the cone is 56.8, and that's pi times by the radius squared times by the height, which is 3.6, times by 1/3. So then we can solve this equation here to figure out what R must be. So to do that, I'm going to do 56.8. and I'm going to divide it by, let me move so you can see, I'm going to do 56.8, I'm going to divide it by pi, or not, I'm going to divide it by 3.6, and I'm going to divide it by 1/3, which gives me this. On this side I've got 15.0666 blah 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 blah, and on this side I've got R squared. And so if this side is R squared, then R would be the square root of that, which is 3.88. So let's just call it 3.88 centimetres. So the radius of my cone then is 3.88 centimetres. The height of my cone is 3.6 centimetres. Now, going back to this, what's super important is that you recognise that this bit, the area of this sector, is the same as the surface area of my cone, because they're the same, they're made of each, like the cone makes the sector makes the cone. So what we can do now is work out the surface area of the cone. Problem though, I've not quite got enough information yet to work out the surface area of the cone, because to get the surface area I need this L length, and this is L. But luckily there's some other maths that we can use to find out what L must be, because I can use Pythagoras' theorem here. So Pythagoras' theorem says that, I should write this up here, that L squared is going to be equal to 3.6 squared plus 3.88 squared. So getting my calculator now, 3.6 squared plus 3.88 squared. That's what L squared equals. If that's what L squared is equal to find L, I'm going to square root that. And so L is approximately 5.29 centimetres. So L is about 5.29. So I'm going to label that 5.29 there. Now at this point, this is just going to take some really hard visualising work, I think, because I just think it's a bit tricky. This is 5.29 here. Now this measurement is also the radius of this, okay? So if you just picture that, if A and B get joined together, they make up this, this length here. So this length, the radius of my sector is 5.29, which is why I've labelled those over there with 5.29. Now, though, we can work out the curved surface area of my cone. So the surface area of the cone is done by using this formula, pi times the radius times the length. So pi times the radius is 3.88, the length is 5.29. Putting that into my calculator, 3.88 times 5.29 gives 64.48 centimetres squared. Okay, So what that means is the curved surface area of my cone is 64.48 centimetres squared, but also the area of my sector is 64.48 centimetres squared. They're the same because of what it told us in the question. So now, we're still trying to work out the angle. That's what the question wants us to get to eventually. It wants us to get to the angle AOB. It wants us to get to this angle here. The kind of formula or the reasoning that we're using to find the area of a sector is this. We think, well, the area of a circle is pi r squared, and then a sector is part of a circle, it's a fraction of a circle, and the way we can generalise that fraction is the angle over 360. So that's the general formula for the area of a sector. Let's apply that in context of this particular question. We then know that pi times by the radius of my circle, remember from up here my radius of the sector, is 5.29. So pi times 5.29 squared times by the angle, I don't know what the angle is, but the angle over 360 equals, and it's going to equal this 64.48 from up here. So then, to work out the angle, there's several different ways you could do it. Personally, what I'm going to do is I'm going to do 64.48 divided by pi divided by 5.29 squared. So 64.48 divided by, I'll move so you can see the calculator input, divided by pi divided by 5.29 squared gives me this. It means the angle divided by 360 equals 0.7334, blah, 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 blah. So if that's what the angle divided by 360 is, to calculate the angle then, we just need to multiply by both sides by 360. So the angle is going to be this, 0.7334 times by 360, like that, which gives me a final answer of about 264 degrees. Okay, and so the final answer here is 264 degrees, correct to 3 significant figures.